Okay, cool, we're live. I realize now that I set the time for 11:50. I thought I set it for 11, but apparently not. So I guess we're a little early today. Hey, how you doing? So yeah, I must have changed it and forgot about it yesterday because I wanted to go live at 11, but apparently I set it for 11:50. So I guess we're a little early. Haven't really cleaned up since last time I was out here. I tend to do things a little backwards. I usually start by cleaning up first. Today I'm thinking we're gonna make the other camshaft. We need this one. Oops. We need this one. I've already made this one. I wanted to make sure I was going to be able to do it and it was going to all kind of work. And it did. So now we can make the second one. And we need the 4-jaw chuck again. So we'll have to grab that guy out. Let's see. Almost there. Just gonna... Oh, yeah, we need this. We need those and this guy. The method I came up with to make this guy seems to work pretty good. Now we're going to do kind of a similar thing to what we did for the piston the other day. We're going to basically leave the part in the 4-jaw chuck pretty much the whole time and just move the whole 4-jaw around from the lathe to the mill and then back. And it's a bit messy. Well, let's clean that off a little first. Oh, hey. Ugh. Oops, hey, what the heck is that? There's something on there. Get out of there. Okay, so this guy I'm going to use 1144 stress proof. It's going to be the same as this guy. Thanks. I try to go for, yeah, I agree with that. I don't want to go with the, I don't like the, how do I put it? Like the easy route sort of clickbait type of content. I'm really not a fan of that stuff and sponsors and all that. I really don't like it. Never been a fan of that type of content. So I really don't want to, can't just turn around and make stuff like that, But it's pretty difficult because it means it takes a long time to make any videos. So, oh, nope, that's 1018. Where's my 1144? I think this is the one I want. 625. It's going to get more difficult too as we make more complex engines that have more and more parts in them. But we'll manage. So, The trick with this, actually I should take the chuck back off so I can play with it a little. The trick with this is that we need to hang the part out far enough that we can get the gear cutter in there. I'll show you what I'm talking about in just a second here. I'm not sure. Let's see. They're all the same size anyway. This might not be the cutter we'll actually use, but where did I put the camshaft? That's up there. So, if the camshaft is sitting in the bar like that, we need to make sure that it's hanging far enough out of the chuck. This, right? So it needs to be far enough out of here that the gear cutter doesn't hit the chuck when we go to cut the gear. But we want it to be as short as possible for the best rigidity. So I think we'll go about here. And this is one thing that kind of sucks about the Shoreline and doing it this way is you have to cut off a big long piece of metal, or you otherwise might not necessarily need to, but I think that'll probably work. That should all fit. I think that'll work. We'll give it a shot. Oh, I gotta stick the vise on the milling machine too. I haven't really cleaned up much since the other day. I kind of just left everything where it is. Oh, it's kind of cold out here today. In that awkward middle ground between spring and summer, it's still kind of cold. Some days it's too warm and some days it's too cold. Okay, real quick. Oh, and where are the studs? These ones for. I really ought to put all this stuff away. What do I got? I need another T-nut. T-nut. There's one. Get out of there. Ugh. And the vise that I put over here for some reason. Okay. The Shoreline's a good choice. The Shoreline's good because they're affordable and you don't end up spending all your money on the lathe and then don't have any money left over for accessories, which is a common trap I see a lot of people get into. You could easily spend more on accessories than you do on your lathe. And so if you can save a few dollars on the lathe, then that's that much more you can spend on accessories. And the accessory catalog for Shoreline machines is awesome. They've got rotary tables, cross slides, accessory tailstocks, angle plates, whole collet set. I mean, you really can't beat the accessory catalog of the Shorelines, and you'll see we'll use it today. A lot of the stuff crosses over between the lathe and the mill. So you have to work kind of a small scale. You know, they're not big machines, of course. You're not going to make a whole motorcycle engine with one, but when you factor in the cost of metal and stuff too, you know, the cost of raw materials is another big thing. It balloons wildly. Like, metal is extremely expensive. You wouldn't believe how much it costs. So that's another sort of hidden advantage to the Shoreline machines is you don't spend that much on materials as well. So then for the same amount of money you might spend on just a lathe, you could buy a lathe and a mill and accessories and material and actually do something with it. So I think the Shurelines are really the best choice. I know I probably sound like a Shureline shill at this point, but. And a pro tip too, even though we don't need the vise to be dialed right now, because all I'm going to use it is to hold the part so I can, just to hold this so I can saw it off. If you put a vise on a milling machine, you always need to dial it no matter what, because if you don't dial it, then one day you're going to walk up and use it and expect it to be dialed, but it's not. And you're not going to check it because, oh, it's always dialed, right? And then you're voice of experience. It's very easy to make a crooked part because you forgot to dial the vise. So even though we don't need it to be dialed for what we're doing, we're going to dial it anyway. It don't take that long either. So it's not that big a deal to dial it. Oof. A little too far. No, no, that's fine. It's just about right. Oh, it moved. Should put washers under the nuts, but whatever. There we go. We'll leave it right there. It should be fine. Yep, yep. A little bit of a belly in the jaws. Yeah, that's fine. Yeah, the vise on the Shureline's a little bit annoying at times. AliExpress lathe. Yeah, the cheap Chinese lathes really are not good, and that's a Chinese milling machine, and I mean it works, but it's not awesome. Yeah. Well, that's good though. That's good if you started with a cheaper machine, then you've probably experienced some of the pitfalls that might cause damage to your nicer machine, so you can sleep a little easier knowing that you know how to use it, right? You won't feel bad about, or you won't not as likely to break something on a good machine. So that's not necessarily all bad. Jeez. Oil. Oops. And yes, as far as making accessories for the Shoreline, yeah, the T-slot lathe table is really handy. I don't think have I made anything to fit the T-slot? I don't think I have yet, but I did make a T-rest. I made a T-rest that clamps onto the table. Clamps on like this. I just copied the one from the Shoreline catalog. I didn't want to spend, it was, they want $250 or something for it, so I didn't have the money for it, so I just made one. But where was I? Put this away while I'm thinking about it. Oops. Ugh. Ooh, geez, it's way off. It's a little closer. There. Better. Come on now. A little too far. Yeah, that's fine. That's probably close enough. Yup. Let's see, where are we at? Okay, so kind of the plan of action here. We're gonna hold it like this, so it's in here like this right now. So here's the camshaft. I don't know how well you can see it. We're gonna turn the OD of the gear. We're gonna turn the camshaft to the biggest diameter that we can. I don't know how well you can see that in the light. So we're gonna turn this diameter of the camshaft, and then this bearing end here. So we're gonna turn all these ODs, and we'll cut this groove, and then we'll stick it in the milling machine. We'll cut the gear, and then put the spindle on vertical, and then we'll kind of cut. If you can see it, I don't know how well you can see it on the we'll switch to this guy real quick. The way I made the camshaft, it's got these facets on it. Now I just cut the facets to be roughly close, and then once we're done cutting all those facets, then with the rotary table, then we'll just file it all the size, all round. You know, this just gets us close. Then we can just file them. I hope that worked out. Yeah, that looks good. That works. Cool. All right. Still trying to figure out how to do this live stream thing. I better put this gear cutter away before I grab the wrong one out. No, I need to double check, make sure it's still gonna clear. Because we need, once we go to cut the gears in it, we gotta make sure we can clear the vice jaws here and get the gear all the way into it. So, oh yeah, it looks like we got a mile. We'll have tons of space. That should be no problem at all. Cool. So I don't remember how many teeth is this? 24, I think. 24. So we're gonna need, that's 17 to 20. Oh, that's right. I don't actually have the right cutter for this. I ordered it from McMaster, but it never showed up, so I had to use the one that was closest for this one. They said 2 weeks, and it's been like 4 months. I still don't have it, so 17 to 20. So I think I use this one because it's the closest to 24 that I have. Yeah, 35 to 54 and 12 to 13. So we'll have to use that guy. It still works. It's just not ideal. You know, it goes in the crankcase and everything works, but it's not optimal. It scared me. Minimize that. Yeah, it goes in here like this way, like that. Then this guy goes in here. This is it's what am I saying? 1144 stress proof, and it's the correct diametral pitch at different ones to make all the different types of gears that you can make. So they're all kind of rough approximations of the radius that it should be, and different sizes, different cutters do different ranges of gears. So you need to, and there's 8 total gears for every gear pitch and pressure angle as well. They get expensive fast. The 48 pitches, there's It's a good size for the type of work that I do. You can use it in a lot of things. It usually works out pretty good. Yeah, I'll listen to this album again. Make sure that's actually tight. Yep, sure is. This tool is ground for aluminum, so it might not be optimal, but I think we'll manage. Okay. Go to 0. I'm going to scribble this one out so I don't accidentally make a second one of that camshaft. If you notice, the gears are in a slightly different spot on the two of them. So the lobe's in the same spot, but the gears spaced out. It's because they overlap each other slightly once they're in the engine. So they have to be on a different plane so they don't hit each other. So we need to go, let's see, how do I want to start? We'll go back. Yeah, let's go back 210. We'll do that step first. 50, 100, 150, 210. Does it seem right? It seems a little long. We could fix it now if we have to, but nope, that's correct. I'm not sure how much I can get away with. I can probably get away with 10. Yeah. Come on. Hands are kind of cold today. They're not cooperating. Ugh. I think oh, you know what? We should try it. We made a command. Although I think there's not much let me put this on because I want to show you guys my YouTube page, but I think if we do exclamation point machines, See if it's in here. That doesn't look like it's working. Stream element. Where's the stream element spot? Let's see if we can get it working. Dashboard. What the heck? Why is the chat bot not working? Custom commands, exclamation point machines. It's not here. Where is it? Why chatbot not working? Yes, I am live. Why is the chatbot not working? What the heck? There's like no option to turn it on. What the hell? No? Bot modules? Why isn't it? Chatbot! It said it's supposed to be working. So if we go to... the bot is in your chat. Okay, it says it's in my chat, but it's not working. What the hell? Ah, whatever. We'll mess with it later. Have more important stuff to play with. Machine tools. Okay, where was I? We're doing that step right there, which is 220 thousandths. So what are we at? 357. 357, yeah, okay. 357 minus 220 divided by 2. 68. Yeah, 68 and a half. Okay, cool. $60, $65. 78 and a half. Okay. Is that? Oh, geez. Hey, easy there, hot rod. So now we need the cam blank diameter, and we're going to turn that back clear all the way to there. 577. Come on, get out of the way. I guess I didn't ask, does the audio sound okay? I haven't changed anything since the last stream, so it should be alright. Zero, so we want 577 up to the flange of the gears. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 60, 70, 75, 67. Yep, right there. Yep, 577. Cool. And what was the cam blank diameter? 429. Right there, 429. My videos will change a little bit. I'm gonna do instead just assembly videos instead of the machining part, because the machining parts of the videos don't seem to really perform. I think they're holding the videos back, so the live streaming I think is gonna kind of replace that in the videos, and then the video will just be assembling it, running it, and flying it. That's the plan anyway. It's all kind of up in the air. Just experimenting, seeing what works. Six and a half, 56, yeah, it's 56, close enough. Damn, again, man. I never catch myself on that. That's never a problem. What the hell's going on today? So 57, right? Wow, those are a little too frequent. I'm gonna turn those down. Those ads are too frequent. Give me some settings on how to do this. And I don't like how frequent those are. I'm gonna set that to that. A little too frequent on the ads. I don't like ads. I know you guys don't like ads. Nobody likes ads, so. Oh, man, set the bench funny. This is one problem with having a freestanding bench is it gets, if the legs get all out of whack, then the whole thing wiggle wobbles around like crazy. But it works really good because I can access all sides of the bench. So premium, yeah. I've got the stream running in a private window because I want to see what it's what it's doing, making sure it's all working and everything. But if I was signed in, obviously I'd be signed in with my account, so it wouldn't really. I don't know how exactly YouTube works, so how all that works. And I think that was actually 556. So let's double check it. It is 556. 556 minus 429. 429 divided by 2. We got 63 and a half. $50. Ow, ooh, went down my neck. 63 and a half, yes. 1, 2, 3 and a half. Okay. So that should be 429. Huh? 429. What am I doing wrong here? That's 53 and a half, dingus. First day in the machine shop, huh? Let's try actually going 63 and a half. $60, 1, 2, 3 and a half. That's more like it. Try that. Maybe that'll make more sense. That'll probably be a little better. Yeah, a little better. Okay, cool. Next, let's do the gear blank diameter. So the gear blank OD 5416. This one's got to be pretty stinking close to right on the money. time is it? 11:42. Numbers are hard, man. 42. It's funny how fast time moves in a machine shop too. So you look away for 3 seconds and then it's been an hour. But then you go on lunch break and a half an hour is gone in a blink. And it's like, I wouldn't mind if lunch break would last a little longer. Let's see. So how far do we need to go? I think we'll go. I don't remember how far back I turned it on the last one, but we want to go far enough that the gear gear cutter, as it sweeps out, we don't want it to. I think we'll just turn it all the way, and we'll probably be all right. Yeah. Anyway, yeah, we'll go. Let's see, 840. Let's go 950. I think we'll be all right. We'll probably manage at 950. Give yourself some extra wiggle room for parting off and. So here's 0, 0. So we're gonna go 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800, 850, 900, 950. It's gonna clear right there. Yeah, it'll be fine. Okay. And we had 557 was our, yeah, so we can just go to 0. It'll be all right. Ow. Okay. So let's see where we're at. Yep, 557, 56 and a half. We'll call it 556 and a half because it actually matters in this case. Dude, again, what is with this thing? Why are you catching my freaking... it's just... I don't want to cut it off, but it's very annoying. Put a piece of tape over it or something. It never catches my apron like that. That's never a problem. Suddenly now it is. Stupid thing. It's very annoying. Maybe we can move it back here. Been there for like 2 years now, and it's never been a problem. Now all of a sudden it is. Now it'll be a little more out of the way because she was catching this stupid pocket. Let's grab my micrometer. Got 550, 550, 555, 6, 7 and a half. So 0.5575, 550, 7 and a half. Okay. 0.5416, 5416 divided by 2, 7 and 8, and we'll go 8 thousandths. I want to make these a little bit smaller than would otherwise be optimal. Because we're using the wrong gear cutter, we want to leave a little bit extra space just for good measure so we know they'll mesh. So we got 7 and 9 tenths. So 5, we got 6, 7 and 9 tenths. We're just going to go to 8. 5416, right? So what do we got? 25, 35, 25, 30, 35, 36, 37, 38, 39, 541.6. We got 539. Man, how'd that happen? What the hell? Read my mic wrong? No, I sure didn't. It's way undersized. Damn it. That's all right. We can still use it, but it's not optimal. This is one of the problems with using the wrong geometry of tools. It probably built up on the edge a little bit. Unless I counted wrong, but so we got 5, 25, 30, 35, 36, 37, 38, 39, 539. So I'm gonna write that down. We can make it work. 539. We'll have to account for that when we set the depth of the cutter. Toolbox is really pretty. Which one? This one? That's funny because that's $80 from Harbor Freight. It's not exactly a high quality one. But so no Gerstner here. I can't quite afford them. Most machinists can't. So we got that. Now we need to cut. Let's see. We need to do the bearing on the end. So before we take that out, let's do the bearing on the end. So Z depth 170, 50, 100, 150, 60, 70. Oops. Looks like there's some shmoo on there. Still need that mic. Why'd I put it away? Hey, good real life getting in the way. Thanks for stopping by. I'll see you around. So we got 216. And I think this one, 55.5. 60s, we got 30 thousandths. Sound right? Yeah. I'm gonna double check just to be sure. Should have 20 thousandths to go. Yeah. What the hell? Where am I? 57. Okay. Okay, we'll polish it from there. What's this one? 400? Oh, it's pretty nasty though. Yeah, let's grab a new one. 400. Let's leave it up here for now. Where did I put my scissors? Ooh. Yep, that should work. If not, we can always go a little further. Okay, so we got most of what we need. So all the turning with this is done. Now we need to turn that groove, and then we can put it on the milling machine, cut the gear. And I think, because we only need to go, it'll probably still hit that flange a little bit when we actually cut the gear. Won't be enough to care about though, I don't think. So long as it doesn't hit the chuck, which we should be all right. It'll be close, but we should be all right. Parting tool. Oops. Ugh. And that's 577s. 50, 100, 150, 200, 250, 300, 450, 500, 550. That's 550, 60, 75, 67. So it should just barely clip that edge. So what we're going to do, we're going to set a stop. Don't really need it. We're going to set it just to be sure. And we need to set a 0. There. And we need 220, so whatever this is, 430 something, it's not 430, it's supposed to be 429. I forgot what it actually is. Yeah, it's 429, so 429 minus 220, 220, divided by 204, 2 turns. So we'll go back up to our stop, 57. We can take it loose now, we don't need it. And let's go ahead and cut our groove. Actually, I should probably go the other way now that I think about it. I should probably go from the outside in, that way we're not losing any rigidity. So I should put that stop back. And we need to go, so 577 minus 40, it's 40 thousandths wide. So how many, let's see, actually we'll just go 420, yeah, that's easier. Plus 0.040, and 460. So we add the width of the parting tool. So if that's our parting tool, just carry the Q-chips. So then we need to go 420 plus the width, it's gonna be 460. So if that's 550, here's 500, here's 450, 460 should be there. We'll double check it. I'm just gonna eyeball it. How's that? Yep, about 420, that's about right. Cool. Okay, now we can cut our groove. $104. So I'm going to go 10, 20, 35. Do the same thing again. Ten, 20, 35. It's getting warm enough now. I can turn the heater off. It's starting to burn my knees. Ten, 20, 35. And then it was 577, right? Yep, 5, so that's 550, 60, 75. Our stop's got something on it. So we're gonna go to 557 right there. Should just touch. Four, we'll go across. Clean up the bottom. Cool. So there we go. That should be all the turning work, at least for this side anyway. I'll have to put it back in, turn the other side, but for now, we can deburr it. Let's double check our length. I think it's probably fine, but yeah, 570 something. That should be all right. Take this guy off. Yep, that'll work. Okay, now we need to clean up the milling machine because it's kind of a mess. Get rid of all this crap. Actually, let's put these away first. So they're out of the way. Actually, I want that rag back. I need you again. Hang on real quick. Let's do this. Okay. Need the rotab. Come here. Actually, let's see. Oop, hey. Guess we can turn this guy some. Let's see a little better what I'm doing. Still pretty far away, that guy. Today we are making one of the other camshafts for this 4-stroke engine. We're making another one of these guys. I know that's out of focus. This GoPro doesn't focus very well close up, so. More. A little more. Yeah, that works. Oh. Lighting's not very good. I think we can improve it a little. Maybe let's move this guy over here. See what we're seeing a little better. That better? I think so. Okay. So we can move all our crap over there now. Need that guy in a little bit. Let's see. Oops. Oh yeah, this goes over here. This goes in there. Okay. Oh, actually, let's put this on there first before we put the spindle on. Let's see. Do I have any that have the... Yes, I do. Oops, wrong way. There we go. It's pretty close. Probably gonna move when we do up the nuts though, or the clamps. No, looks okay. We're doing good so far. Well, it looks pretty close to me. It'll definitely work. Yep, cool. Sweet. Spindle. Okay, now I don't think we want this guy on there. We can take him off if we can afford to. We'll take off the extension plate and then should be able to run spindle straight on there. It's one of the nice things that I like about the Sureline machines. It's real easy to move the spindle around. You just turn it sideways like this. Get on there. Like that. There's this guy right there. Need a drawbar. It's just a bolt. Whack this guy in there. Come on now. Don't be difficult. How does it look? Yeah, that'll work. It's not great, but it'll work. I think this one's half inch. No, 7/16. Okay, gear cutter. Yeah, let's see. It's not the right one, but it'll work. It's the only one I got. That's close enough, it'll work. Okay. I want also change to this pulley. Oh, ow. It's sharp. There we go. Okay. Now I've got kind of a cheeky method to align the cutter on center. There we go. Oh, come on. There we go. I just use a strong loop and line it up on the turning marks, and it worked pretty good. I know you guys can't really see what I'm doing here, but there's no good way to out there. 0x. We're gonna lock it as well. Yep. Now I gotta make sure I set this to 0 so that I don't forget. Cut the first tooth at some funny angle, and then we have to use that funny angle for the rest of them. And make sure we start at 0. And actually, let's move it from 0 first real quick. See how far we can go before we hit the chuck jaws. We can go pretty far. So there's about roughly 0. Oh yeah, we'll have plenty of space. Oh, tons of room. Cool. So back to 0. And plug spindle back in might help. Okay, so X is locked. We gotta find our 0 instead of good slow spindle speed. It'll probably work okay. So we're just gonna reach in there and touch it. There it is. 0y. Realistically, it's closer to -1,000, so unfortunately we can't set the shoreline to, we can't set the DRO to a number, which is pretty annoying. We'll set it like that, about there. Nope, we don't need to lock it yet. So what we need to do, we need to feed it in. The infeed's 45. On the last one I went 46. 46 anyway, but this time our OD is about 2 thousandths small. It's about, yeah, let's calculate it. So 5416 minus 539. So it's 2 6/10. So we want to compensate by 1 3. So we'll call that, yeah, let's see. So if we were going to feed in 45, we'd feed in, 1 3/10 less than that. Oh, 45 minus 0.013. But what I did last time, I fed it in by an extra thou to give it, because we're using the wrong cutter form. oops, we want to go a little bit deeper to give it a little bit more clearance so that the gears run correctly, as correctly as it can. So we'll go 44 7/10. So we're gonna, well, it's 44 5/10 anyway. Can't read. Oops. 2, 3, 4, and 5. Oops, it's a little too much. 4, 45, and a few more. We'll do that, and that should be all right. Gears are actually a lot more tolerant of goofiness than you might think. Oh, good. I'm glad you liked it. I got into machining in high school. I took a machining class, and then I've been doing it professionally ever since. Plenty of clearance to the cam blank. Yep. Cool. All right. Cool. Let's get a little bit set up here. So we need 360 divided by 24 teeth, right? I think it's 24. 24. 24 is 15. And then we're going to store that in a register. Hey, it didn't store it. 360 divided by 24. Store A. There we go. Oops. Recall A. So now we have 15 in the A register. So now we can go, we're going to start at 0. And then we're going to add the A register and it'll go to 15. Then we're going to add the A register and we'll go to 30. So that's a good, easy way to help with gear cutting indexing on the rotary table. Because then when you got funny numbers like, what was it, 20.315 or something, you don't have to type that in every single time and risk making mistakes. Because like when you're doing goofy dimensions and stuff, like you know, I don't know what, 33 teeth or something. What's 360 divided by 33? Oops. 60 divided by 33. So when you got some silly number like that, it's a lot easier to just put that into a register than it is to try to remember it and type it in every time. So yeah, let's go ahead and start cutting the teeth. You gotta make sure. Actually, you know what I did last time? Yeah, it'll be all right. We'll figure it out. It'll be all right. Not very comfortable to cut gears like this, but it does work. Once we know a good Z depth where we're not going to hit the chuck jaws, then we can set a 0 and it won't be quite so bad. Then we can just pay attention to the DRO. It's hard to tell. I think about there is probably close. How's that look? Looks like we might not quite be there. Let's go, let's see. Let's go cut another tooth. We'll go up, is it 15, right? So it's 3 rotations. 1, 2, 3. 1, 2, 3. So yeah, let's cut a tooth at 30 degrees. So that chuck jaw is right under the cutter. And then we can see how far we can go and get away with it. Make sure we're not going to hit them, because I don't want to hit the chuck jaws. Not only are they hard, but I don't want to put dents in them. This cutter is actually worth almost as much as the chuck is, so I'd really rather not break it. Oh, Jesus. Goddamn thing. What the hell? Please don't do that. Did you see that? The stupid thing got caught in the cutter. I don't know how did that happen before. Well, it could have been a lot worse. Talk about not breaking the cutter and then immediately get something bound up in it. Good job, dude. Hope that didn't hurt anything. Doesn't look like it did. No, the teeth look fine. Does part look okay? Yeah, part looks fine. Don't see anything weird. I think we'll get away with it, but... Are you awake now? I am. Try going from above instead. Still sounds fine. Closer artery to the chuck. I'm pretty close. We're at plus 20 thousandths. What do we got? It's hard to tell. I think we got quite a bit though. Oh, we got a mile. We got tons of space. What's that? Maybe we keep going. Let's go. 10 more. Okay. I think that's pretty. Yeah, okay. I'll leave it there. We'll call that 0. Probably could have stuck the part out a little further, but oh well. Too late now. How's that look? Let's wheel it around. It looks like it. Yeah, it looks like it's fully formed for how thick the gear will be. That should be all right. Yep, looks good. Hello, how you doing? We're making a camshaft today. We're just cutting the gears now. Cutting the gears into it. I'm gonna go back to 0 and make sure we get that first one all the way down through. 0, okay. Down to 0, cool. Now we can go, just to make sure we're not doing anything stupid. Recall A is 15, yep. 2, 3. We only had to cut the one at 30, so we can plus recall A, 30 plus recall A, 45. 2, 3, 1, 2, 3. A, 60, 2, 3. Something's clicking. I don't know what's clicking. What the hell? Is that pulley loose? I think that pulley is loose on the motor shaft. It's hard to tell. You might have heard it clicking. I don't know why it's clicking. That's weird. What size wrench it is. I think it's this one. Oh, it sure was. Yes, it was probably that. Oh yeah, that's better. Cool. Okay. Weird. This one's glow. Although it wouldn't be difficult to put a spark plug in it, which I want to do at some point. So we cut this gear. We call it this tooth 75. Okay. 1, 2, 3. $105. $105. Ugh. Yep, still looks good. Okay, we're halfway there. Cool. Isn't gear cutting so exciting? It's just so very interesting. Wow. Cool. I'm out of soda and I want some more, so I'm going to run inside and grab another soda. I'll be right back. Please. Okay, I'm back. Soda has been acquired. And this rotary table is decimal. It's all decimal. So it's got every 5 degrees here. and it's got each rotation is 5 degrees, so each 10 divisions is 1 degree. So it's all decimal, no minutes or seconds. It's much easier to deal with. Okay, where was I? We're at 180, so we need to go to whatever's after that. 195. 1, 2, 3. 195. The rigidity's not the best. The Shoreline, that's the one place the Shoreline mill really kind of sucks, is they're not very rigid. So this is kind of pushing the limits on size. I wouldn't with this setup, I wouldn't want to make it really any bigger a gear than this, or in any harder to machine material. For most like small hobby stuff, it's totally fine. But I mean, I bought a bigger mill after all, so for bigger work, it's not a good option. But for really small work, it's so easy to use because it's got a much better feel to what you're doing versus versus the bigger machine. Like the little steam engine that I made would it would have been way harder to make on the big machine than it was on this one. This made that super easy to do. .45. Okay, it's the last one. We're almost there. Blow all that crap out of there. Cool. All right, gear's made. Sweet. Yep, looks good. Okay, let's get the gear cutter out of there. Away. Get him out of there easy. There he goes. Oops. Oh, come on now. Okay, now we need to put the spindle back on vertical. Then we can cut the profile of the camshaft. So we'll unplug it again. And I think we need the spacer block. I think we can get away without it. Yeah, we'll put it on there just for good measure. Pain in the nuts to have to take it all back apart. Don't fit. Okay. I don't like having stuff on top of workbenches because when I sit down, my knees can't go under it. Because when I sit right here, my knees go under the table. So if I can't do that, it's super annoying. It drives me up the wall. That's why I like have a bench with no bottom on it. And then I can't really do it with this one, but usually I'll sit at the workbench too. That's I usually don't really like those type of workbenches. They tend to be just kind of annoying to me. So let's take it back to the high speed mode. Oh, come on, where is it? There it is. Ow, ow, ow. Come on now. Yeah, there it goes. Okay, so need to dial it. Hopefully the indicator fits. I think it will, but it might be close. Stack a bunch of stuff up like this, it gets hard to fit an indicator in the spindle. I want to, me being the weirdo that I am, I want to make a smaller indicator. I don't think you can really buy any that are smaller than this one. I keep thinking about it. It'd be pretty cool to make one. I've got all the stuff to do it. But it would take a while. I don't know if I can go that long between uploading videos. And I don't know that making an indicator would be all that interesting of a video. I don't know. Oh, it's not gonna reach, is it? God damn it. That's annoying. It's very annoying. Damn it. Wonder if we can do this. No, I don't think that's gonna work. If we put it in there like this, but it's gonna be too wide. Yeah, it's not gonna work. Oh well, just gotta take it off and put it back on. We'll dial the rotary table instead of the part. Took the part off. What a pain in the nuts. See, the size of this machine can be really annoying at times. Okay. Careful, we won't have to clean the whole thing off. Just make sure the bottom's clean. We don't drag a bunch of stuff around to it onto the bottom. We'll get away with it. Get away with it. It'll be alright. Yeah, that's fine. Of course, it's gonna not really fit anywhere. I've had a few times people comment that in my videos you don't really see all of the dialing and setup and all that sort of stuff in the videos, and yeah, they're very right. It's especially when you're only making a single part, it can be a lot of many hours of dialing and adjusting and playing grown-up Legos for 10 minutes of actually making something. I went too far. I went way too far, geez. Yeah, I'll go right there. Yep, that'll work. That'll be fine. Camshaft and a model engine don't have to be that precise anyway. We can get away with it. Okay. Let's see. I made another print with some more info for the camshaft. See if we can find it. I don't know where I put it. I don't think it's down here. Nope, must be up here. It's up here somewhere. Just a bunch of hardware. A whole bunch of random nonsense. Let's see. Come on now. There it is. So, I don't remember what size cutter I used. So if that's, let's see. What did I measure that? Oh, that's good. Okay, let's see. That is 280. It's 140. 299 is 159. Okay, so 159. It's 159 from here. And so, what size tool should we use? I don't want to use a huge cutter. If we use too big a cutter, like this isn't very rigid. That's kind of just hanging out on a pole there. So if we use a big cutter, it's going to tend to wobble that around. It's going to vibrate and chatter. So we want to use something small. probably 1/8 inch will be good. And then I think we should be able to use, if we use the 1/8 inch tool, then we can also put it in a collet, so it'll be real nice and short. That one looks like a good choice. I think we'll use that guy. Important with the Sureline machines, you got to maximize rigidity as much as you possibly can, because they're really sort of lacking in that regard. So it looks a little worn. Yeah, we'll use that side, it'll be all right. It's a 1/2 inch. Okay. So if we're using an 1/8 inch tool, this guy, 159, 25 divided by 2 plus 159. So we're going to go to x 0.2215. And this cam, so the other cam has a space where the cam lobe is. This cam has the cam lobe on a tooth. So this time we can start at 0. Last time I had to offset it by 1/2 of a tooth width, or 1/2 of a tooth space, to get the cam lobe on the center of the space. But this time we want the cam lobe on the center of a tooth, so we can just go straight to it. And if I remember right, just went. So we want to go from. So that's going to be 90 degrees actually. So we want to go 38.64 degrees. Right? Does that sound right? I can't remember how I did this last time. So we want to go. Okay, no, that's the right. Yeah, that's the right one. So we go. Yeah. Okay. So if we go 38.64 degrees that way, we're going to go the other way because I want to do it on this side. And then we'll cut into a 2215 radius. That should get us close. I think we'll probably go to 222 instead. Same thing. You don't necessarily have to. You probably should. To tram it, it's for most things it's usually close enough. It depends on what I'm doing. If I'm doing something that really needs to be precise, then yeah, I'll tram it all. But a lot of times, just for general work, it's not hugely critical. So if we go 360 minus 38.64, so we're going to go counterclockwise to 321.36 degrees. So there's 315, 320, 321.123 degrees. Oh, that might not be long enough actually. I think it's gonna hit the, yeah, it's gonna, damn it. Oops. It's gonna hit the collet there. So we get all the way down. Damn it, I'm gonna stick it out further. That sucks. So, to get it right, I'll just set it about like that. Hang the tool out far enough. Only just, but yeah. Okay, that should work. Didn't do a very good job of that, did I? Will it reach now? I don't like how far that tool's hanging out, but we're gonna have to deal with it. It'll be all right. I think we'll manage. Okay, set to 0 there. So basically what we're gonna do, so right now we've got it turned over this way to cut this flank here. And so now we need to just cut into 2215 radius on the X, 2215. So double check that makes sense. I'm just going to go to 222 because we're going to file it as well. Yeah, that looked right. Okay, do my angles make sense? I think they do. If we look at it this way, and we were to go 30, whatever this angle is from, if we keep that level and we go to like this, then that's coincident with the y-axis. So I think we'll be all right. And we'll do that same thing on the other side. And then once we get the other side done, then we'll do the base circle. And it has two angles as well. Well, I guess they go this way, but yeah, we'll get there when we get there. Hopefully this isn't too loud for you guys. The spindle gets a little noisy when it's on the milling machine for some reason, but I think we'll run it pretty slow, so it shouldn't be a problem. You really can't see much, can you? I can't see anything, geez. Let's take this guy over here. Better? Yeah, it's a lot better. .22. Okay, so there's the first flank. So now we can go to this angle on the other side, 38.64. So 30, 35, 6, 7, 8.564. We'll go this way. Does that look right? So if we had this guy straight like that, oh, something's fishy. Did I get my angles wrong? No, I can't tell. No, that looks fine. Yeah, that looks right. Hello. Yeah, making shafts can be awkwardly difficult. They're so long and spindly and weird. They're hard to hold. Let's see, I'm gonna double check this. Make sure I'm totally right here. It does seem like it's a little funny. If we goof up one face, then we can still save it. But if we goof up two faces, yeah, I see something's fishy here. We line up. Oh, sorry, never mind. That's the wrong one. It's because I'm a dingus. I think we're all right. I'm lining it up with. This one's the base circle face. This one's the top one, so I'm not sure. I don't have a compass handy. We'll just go That intersection is about 2 inches 100, so we'll go 2 inches 100 this way. 2 inch 100. Draw this line tangent to that. About like that. So now if we line up that one with this one, then this, okay, this is coincident with Y. Okay, so we're good. We're fine. Okay, here's the second face. Now we need to do a whole bunch more angle figuring. I don't remember how exactly I figured all this for the other one, but we need to figure out where to put it this way. So we need to go this way that much, and then whatever this angle is. Because what we're gonna do, we're gonna turn the row tab this way. We're gonna feed in, and then rotate the base circle around to this angle, and then feed out. And we need to, yeah, okay, it's easy enough to figure out though. I think. Can usually be kind of awkward. Let's see, this guy right here. That's what I was looking for. Does that look the same? Yeah, the end of it looks about the same size, so I think we're in pretty good shape. So, for this guy, I'm going to go minus 20.05. So we're going to go 360 minus 20.05. So we're going to go to 339. I'm going to write this on a index card. So we're going to start at 339.95. 339.95, yep, okay. So that'll be here, right? So if this is 0, we're going to go back minus 20.05, and then we're going to feed in. And once we hit 0, we need to figure out what is this angle all the way clear way around to there. And that is going to be 180. So we're going to, so it's 20.05 here. It's going to be the same on this side, plus 180. So 0.05 times 2 plus 180 equals 220. So we're going to go this way 220.1 degrees, and we're going to stop, and that's actually going to be 339.95 plus 220.1. Was that 220 point? Yeah, okay, so which is 560 to minus 360. So we're going to go clockwise around to 200.05. Does that sound right? I think that sounds right. So what we'll do, we'll just do a skim cut on the top and make sure it all looks correct before we go all the way. And the radius is 280 divided by 2 plus 0.0625. We're going to do all that at a radius of 0.2025. So we're going to go 203. We're just going to go 203. Okay. So let's go ahead and do this. And we're going to start at 339.95, 330, 335. Let's see, that's actually real quick. Wipe off all my marks first. That guy. I like to put marks on the table here so I know where to go and where to stop. So there's a mark. I think that's all of them. Yeah, it looks like it. Okay. Said something. The lobe to the gear, I cut the gear at 0, and I didn't move the rotary table or anything at all, so it's not going to change. And when I dialed the spindle to the center of the rotary table, so that our X0 was relative to 0 on the rotab, but we didn't move anything relative to the 0. And I just realized why you brought that up, because I took it off. Brilliant. So I guess I didn't. This is one of those things. This is how I struggle with. I really struggle with this stuff because I can't work at a slower pace. You know, it'll be close enough. It'll work out. I see why you said that, because on the last one I didn't take the part off, and so the part didn't move on the rotab. But now I see what you're saying, because this is kind of why I've always struggled, especially in the real world machine shop, because I always forget stuff like that, like constantly, and it's something that never changed throughout my career. So I've really struggled with stuff like that, really bad. But I think last time when I did this one, I didn't take the I dialed the rotary table before I put the chuck on it, and then I used that 0 the whole way through. And so yeah, cool. Close enough, it'll work anyway, but that's incredibly disappointing. I wish I could say this. I wish I could blame this on live streaming, but I do stuff like this all the time. It's plenty close. It'll still work. You'd think after all these years I've been a machinist, it's literally the only thing I've ever done. You'd think I'd be able to remember and catch stuff like that, but I sure don't. So anyway, so I'm gonna start at 339.95. 330, 330, 335, 5, 6, 7, 8, 9, 339.95. I don't really need to lock it, but so we're going to start at T. I start at T. I put a mark here. T. So that's where we're going to start. And we're going to go around. Well, I put this arrow the wrong way. We want to go clockwise. Ugh, jeez. Clockwise to 220.1. Oops. So we're going to go this way. $210, $210, $215, $220.1. Nope. It's 220.1. So then we're going to stop at Y. And then Y is going to be right here. So we're going to start at T. We're going to stop at Y. No particular reason for using T and Y. They've just got good lines on the bottom of them to indicate where they're at, to point at something with. So there's no real reason for using T or Y. They just seem to work pretty good. So we're going to start at T. I once threw away a part that I worked on for about a week and a half to make this one part. It was, I mean, still to this day, it's probably one of the most convoluted and ridiculous parts that I've ever made. And it was going perfectly, and everything was working great. And this is total prototype, seat of the pants. They needed one single part, sort of really super goofy, extremely convoluted part. It was a colossal nightmare to make. And the first part was coming out, absolutely perfect. It was just going absolutely awesome. All the dimensions were right on the money. There's weird angularity and GD&T stuff. Lots of really tight tolerances and annoying true position and stuff. Just goofy, weird angles all over the place. The thing was really thin, had protrusions coming off of it at all sorts of weird angles, and we had to make it out of solid. And it literally took about a week and a half to make this stupid thing. And this was on a CNC machine, and I was about 10 lines from the end of the program. And the last thing we were doing, I mean, I could see the M30. The M30 is the end of the program, right? And the last thing that we did was we just put a chamfer on a hole, right? There's a hole bored straight through the center of it. And the last thing to do was put a chamfer in the hole. Well, earlier on, when I was making some of the tooling, the programmer, and I don't blame him for this. This is one of those easy things to miss. He missed a compensation for the chamfer tool to cut a chamfer on the like this, into a thread for the center of this, for a bolt that went through the center of the fixture to hold the part down. And if it's one of those things, rather than go bother the programmer about it, you could just go, you can just compensate for the size of the tool, and you can just kind of basically tell the machine the tool is way smaller than it is, and it'll just cut bigger. Basically, it's really simplified. And so I just comped it out, like 100 thousandths or something, and didn't really think about it. That way I don't have to go bother the programmer, and he's got a million other things to do, and I'm just going to get on with it, right? And so I chamfered the fixture, and then kept working through it. And the last tool was just putting a chamfer on the bore through the center of the part, which consequently is the same bore that fixture went into. And but I forgot to take that comp out of it. I forgot to take that like 100 thousandths compensation out of it, and so it just ground a big, huge groove all the way around the hole. I mean, it didn't even touch the hole. It just ground a groove all the way around it, like 10 lines away from the end of the program. I spent like a week and a half working on this stupid thing, and that was a really bad day. I was not happy. I was very, very mad that day. That was probably the most boneheaded goof up. I was very mad about that one. Ugh. That was a bad day. That was the only time I ever just said, you know what, I'm just gonna go home for the day. I'm out of I just can't. I just checked out and went home. I was like, sorry, I need to leave. This is bad. I feel like the most useless goof today, and I'm just gonna leave. Yeah, that was rough. It was not a fun day. So we're gonna go into 0 and wheel this guy around to Y. Did I pass it? No. Here it comes. Here's Y. I'm gonna go up to Y and out. Oops, something's fishy. It shouldn't have cut on the other side there. Where did I mix up? These numbers are funny. This is 20.05, right? 20.05 plus 180. Plus 20.05. So why are my numbers all sorts? Am I getting different numbers now? Yeah, 220. Right, plus 339. Yeah, okay. 339.95 Hey, zoom up. Which is where we started. Or did we start at 339.95 for this one? Can't remember. 360 minus 20.05. Yeah, 335, 330. Yep, okay. Yeah, so that's where we started, 339.95. Now we need to go clockwise. 20.05 plus 180, so 20.05. 180 plus 20.05. So 220.1. Did I go to 220.1? I did. That's why. That's what it is. That's what I messed up. I set my numbers in the wrong spot. Okay, that makes sense. So it's supposed to go to 200.05, not 221. Okay. Really don't like it when all the numbers work out to be just about the same. It makes it so easy to do stuff like that. $200.05. Okay, there we go. That makes more sense. So 195, 200.05. Let's try that again. So here's now. Why? I even put my number in the right spot and didn't go to it. Nice, dude. So here's why. It's right there. Let's try that again. The worst part about working as a machinist in the professional world is when you're having an off day, you don't really get much choice. You have to do it anyway. There's no choice in the matter whether you work or not. I mean, it's like, and machine shops aren't exactly accommodating. No one really cares about the human factor. It's quite a miserable industry in reality. Okay, let's try that one more time. We'll go down a couple thousandths. And our radius is going to be 203. So we're just going to go to like 210 or something, just for good measure. Into 0. And around. There's Y. 200.05. And out. Okay, that looks a lot better. That actually makes sense. That looks much better. That actually looks like camshaft now. Okay, cool. Blocked. Okay. Lock that. Now, so start at T. Let's see. How far do we want to go? We're at 0 now. Just about at 0. We're just going to start right here and see what we get. It might be too much. Nope, it's fine. What the heck? Oh, great job, genius. That's 60, and we want 50. There we go. It's 250, we go to 240. Where's T? Where's T? There it is. Okay, there's 240. Was that 240? I think it was 240. Yep. $220, 43, $220. $220, let's go $210. Sure, close enough. Went a little past. Oh well, not a big deal. Oops. Okay, now we got, so we're close. We need 203, so we're going to go to 204, 205. Whoops, that's 180. Let's see, what do we got? Let's go 205. Let's go 205, and then we'll go 203. It's T. I'm going to go to 203. 6, 4, 3, 3. Okay, cool, there it is. There we have it, 1 egg shaft. Yep, looks about right. Let's compare it to the other one. Did I put it away? Probably. Nope, it's right there. Yep, looks about right. I don't know how you guys can see it. Looks okay. And I think we can work with that. So, that done, and we can stick it back in the lathe. And I'm going to turn as much of the backside as I can, and then part it off. And then to finish it, what I did for this one, I stuck it in a super glue arbor. So we won't be able. So what we're going to do, we're going to do the same thing, but we won't be able to see that one finished today because it has to soak overnight in acetone to get it out of the super glue. But at least we already have one. We can kind of look at it. So make sure before I take this out that I got everything. I think the only things we need to do on it here are just the gears and the camshaft lobe. Yeah. So, I mean, those are the only features on the thing. So, because the backside, all it is that other bearing, and then a little step is all it is. So, actually, yeah, I think, yeah, looks fine to me. Cool. All right, let's take it off of there. Okay. I don't want to heat up the part because it'll draw the temper of the material. Yeah, machinists, not a good group overall. Machine shop's not a fun place to be, usually, unfortunately. Because it's the only thing I know how to do. Let's put this guy back. Okay, we put that away. Let's put that away here. Still need this one. Ah, put stuff away. Put that guy away. Put these away. Ow, ooh, got one, finally. There we go. Oops, hey, get it. Okay. Now we need parting tool. Uh-oh. I got some chips in my sleeve. That's a bad sign. It's over now. Where are they? Oh no. It's like when you get one in your sock. You can never find it, but you're at work, so you don't have a fresh pair of socks to change into. So you have to just deal with it. It's the worst. The worst. It's 11:44, yeah. Where we at? About there. 10, 20, 30, 41. 41, and it is, how long is it overall? Remember. 840, so we go with 850? Yeah, I think we'll get away with 850, that should be fine. So here's 0, right? That should be 0. Yep. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600, 650, 700, 750, 800, 850. Yep, that'll work. Yeah, we don't need to lock it or anything. And back to oh, I gotta turn that camera back. I forgot. I want to get more cameras so that I can get sort of better views of what's going on closer to the machine, but this is kind of the setup that I have right now. I want to spend 6 years shoving cameras around because it gets, be surprised how annoying it gets. And come on, wrong way. A little more. Of course, now it's, there we go. Oil, where's my oil? There it is. And my soda. This is probably going to sound awful right as it starts, but it should settle down after a second. Cutting through gear teeth always sounds nasty. So, double check our number here. 840, yeah, close enough. As far as eyeballing it goes, that's plenty close. Oh, yeah. Plug it back in. Ugh. How close are we? Can we wiggle it off of there? Oh, yeah, cool. Sweet, there we go. I was worried about some people would get motion sick with it. This camera doesn't have any stabilization on it, so if it works out and I want to keep doing it, then I'll get a better camera with motion like stabilization, so it won't be quite so shaky. This is kind of an old GoPro. It's just one I had laying around. Okay, let's get this thing out of here. And Forge jaw is now packed full of chips, so I have to clean it before we can use it again. I think we're just going to use the 3-jaw for the next operation. Set it here next to the kerosene. Okay. Switch back to high-speed mode. Three-jaw chuck. So this guy is, what is he, 500 and something diameter? 540 diameter, so he's a piece 3/4 inch something. That's 2024. That's our scrap piston. We should mark that as being 2024. Oh, come on. Stupid Sharpie. So I don't forget that it's good metal. Expensive. I don't want to use that for a superglue arbor. It's a bit of a waste. What do we have that'll work? That might work, actually. Yeah, that'll work. Let's make it a little longer. Stick it out further. There we go. Okay, cool. Now we can make our arbor. Turning tool. Yeah, a vacuum doesn't work for the oil-soaked chips, though. It doesn't really suck them up anyway. It's good. It'd be good for that machine, of course. It's covered in aluminum, but other than that. Probably got a bunch of junk in it. Maybe not. We're building a, well, it's all tore apart right now, but it's a, let me open the CAD machine, I'll show you the CAD drawing of it. It's a single cylinder, 4-stroke, 4.5 cc's. And I got most of it done. We just need to, we made a piston on the last stream. And so we need just the carburetor and the connecting rod and this camshaft. This is what we're working on right now. We're making another camshaft for it. I've got one of them, but it's got two, so. And it is right here. Let's go switch to CAD machine. There it is. Here it is. So this is what we're building. And we're making this camshaft right now. Was this one or is this one? Anyway, they're both pretty much the same. So after that, then we just got to build the make the connecting rod, that guy, and the carburetor. And I think that's pretty much it. I think then we're done. Oh, I gotta make the push rods too. Get some screws and yeah, here's all the parts so far anyway. Yeah, this thing's gonna be fun, dude. I'm really excited about it. It's the first 4-stroke I've made, so here's the cylinder head. This is the first part I made. I always like to start with the most difficult part and work my way down to the easy stuff. Okay, where was I? We gotta drill that guy through. How far through? All the way through. What size? So we want to drill an reamment for 156. So we need something a little smaller than that. What size is that? 530 seconds? Is it 530 seconds? Yeah. What the hell's 530 seconds? It's 156. It's that one. That's 100. Nope, too small. 150. Yeah, that'll work. That'll work. So basically for the superglue arbor, we're just going to make something like this. If this is our cross section, we're gonna do, and actually I put a step in here and put a step in it like this. Put a step like that, like this, so that the cam will sit in here. The end of it will be held in this guy, so this will be the end of the cam, and then the cam lobe will fit here, and it won't touch anything. It'll be free floating, and then the gear will sit right here. The gear will sit there, and we'll super glue it in there, and then we'll turn the other bearing end on the end, or the other shaft on it. Okay, so we need that size of a hole. This guy's the one we're going to use. There's already, looks like a hole all the way through it, so we can just drill it. Actually, ooh, you know what? Should use a bigger drill in this, or smaller drill in this, because it's going to end up off center. So we'd better drill it small, and then run a bore bar through it, and then ream it. That way we know it's on center of the spindle. My music stopped like an hour ago, and I didn't start it again. Yes, this is my first 4-stroke. Come on. Should I listen to? That's a good one. Hopefully the first startup on this one's a little bit quicker than the twin cylinder was. That engine took about 2 weeks to get running. Might have been a little more than that. I don't remember. Oh. Oh, okay. Guess the hole's not all the way through. About to be. Okay. Is this guy gonna be long enough? I don't know. Ooh. Probably not. Okay, so what we're gonna do, we're gonna turn this first. Yeah, we'll do that first and then we'll do the through bore. How deep does that need to be? I'll put these away, I don't need them right now. It needs to be 577 minus 170. So that's going to be 407. From here to here is going to be 407. I want to go a little deeper so that it clears that ledge. So if we go to here, if we add 20 thousandths, 427, we'll call it 425. Just make it an easy number. So we'll go 425, and it's going to be 429 diameter on the blank. So if we go, how big do we want to go? Too much bigger than that. So we'll go 20 over that as well. So 430 we'll call it, plus 20 is 450, diameter 450. So on our little doodle here, from here to here is going to be point, I forgot already, 425. 425, that diameter, 450. Then this depth, we're going to go, let's see, it's just 93 to there. So we'll call that, we'll go 85. So this is going to be 85 deep, and the diameter will be the gear blank diameter. We'll just make it big enough for the gear blank. Yeah. Which I don't remember what the gear blank diameter was. I forgot. Just somewhere in the neighborhood of 541. Yeah, we'll call it 540. We'll call it, diameter 0.539 to give ourselves some wiggle room. We'll just turn it to fit. So first thing we're going to do, so that's 425. 425 plus 0.085 is 510. So we're going to call that 510 instead. Okay, we're going to turn that bore first. Then we have to do that one, and then we can come back to this one. Oh, come on now. Okay, so 0, and we're going to go 510. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, and 10. Oh. Yeah, but it's just kind of crazy, man. Building small engines is a lot of fun. So the V8 actually, as drawn, only has 2 cylinder heads. It's actually just cut up to make it look like it has 4. I won't be able to make, my lathe isn't big enough to make isn't big enough to make them in one piece. So they're sort of symmetrical. I can show you how it works. I have it drawn up. Small engine stuff, whittle V8. Let's open the V8. So it's the cylinder head assembly. Where is it? Where is it? It's in here somewhere. Oh, that's at the bottom. There it is. So we'll actually have to make 4 cylinder heads, which, I mean, there's still a ton of work in those 4 cylinder heads, but okay, so if we change the CAD machine settings, CAD machine, head cam, CAD, oh, there we go, CAD, where is it? Libre design, there it is, okay, cool. And now if we transition to this guy, here it is. I have it, the way I have it drawn at the moment is with the, so imagine, if you will, a mirrored cylinder head over here. And they're the same, but it's kind of interesting the way it's made, the way he did it. If you can see, this is the intake port right here. So there's actually only one intake manifold on each side. So each, the left and right cylinder head, or the front and rear cylinder heads, are one piece, which is kind of cool. But in the center, they were just joined by a web, so they're total mirror images of each other on either side of the front and rear. So in order to in order to make the, oops, come on. In order to make the, what am I trying to say? I lost my train of thought. Where's the assemblies? Where's the cylinder heads? There it is. The cylinder head. In order to do the combustion chamber and the valve seats and everything, in order to be able to swing this in my lathe, I had to split them up to be able to turn that. And yeah, the plans for the V8 are from a guy from England named Eric Whittle designed them in about the 90s, sometime in the 90s. He's done a whole bunch of different style of engines. Let's get, we're on the right one. Yeah, okay. So. Oh, come on now. No, the whittle's going to be put on an airplane. I have seen the diesel Cox conversions. The Dr. Diesel ones, I guess, are kind of annoying because of the way they work, but I have seen those. I've never tried one. Never run one though. 64. And what was it supposed to be? 450. Oops. 93. I hope this doesn't end up breaking out into the... I don't think it will, but this, yeah, 5.7, okay. But, I don't know how long that piece of material is. It actually, uh-oh. Crap, we might end up breaking out. Ooh, this piece of material might not be big enough. I didn't think about that. Now we'll give it a shot, see what happens. If it works, it works. If it doesn't, we'll start over. Oh, come here. 93. What did I think about it? Is this 625 or 3/4? Did I measure that? 625, okay. It'll work, it'll be close. Yeah. No, it'll be fine. Okay. Where are we at? It should be 0, so we should have 90, 40, 43 thousandths left to go. Yeah. I got a Balsa USA smoothie. It's already pretty much fully built. I'm at a point with it now where I can't go any further till I have the engine done, or at least mostly done. $70. So it's 50, 60, 70, 80. 90. So we got 93. 1, 2, 3. Okay, cool. It didn't break out. That's good. So we can drill it the rest of the way through. This guy. Come on now. Something's fishy. Is there a piece of steel on the other side or something? Broke off tap or something? Oh no, it's just got a bunch of junk on the end of the drill. There it goes. Oh, it was like almost all the way through too. It's funny. Like 50 thousandths from the other side when we stopped. Go figure. It's funny. This guy right here. Hang him out a little further. Like that. Hopefully that'll be far enough. Yeah, I'm excited for it. I really want to finish that engine. But there's also, 550 parts on it. When I first started building it, I was going to make a video series doing it, but quickly found out that series type videos don't perform very well on YouTube. So all 3 times I've tried it, the videos performed horribly. I mean, just terribly. So it's kind of hard to do it. Build an engine that's gonna. There's 550 parts in that engine, so it's gonna take a while to build. And it just can't go that long between uploads. I was hoping I would be able to, but it's not gonna work out. So if the live streaming thing works out good though, then we're just gonna build it on stream, and then it doesn't matter so much how long it takes to build. Okay, I think we're okay now. Yeah, okay. These are 156, so if this doesn't go in there, which it doesn't. So, yeah, cool. Okay, let's go 156 reamer in there. Which one is it? It's this one. 155. No, this one. 156. Okay, I was reading it funny. I tried that, and that's what I did with the twin cylinder. And the twin cylinder video actually did pretty poorly. I mean, it still did fine, but it did poorly compared to my nano engine. It actually didn't perform all that well. Not as well as as I need it to, I guess, for how long it took to build. I think it's sort of people had already seen parts of the series, and so they didn't necessarily watch the whole entire twin cylinder video. So my plan going forward is to just build the engines on stream and then then the actual video will just be assembling it and running it and flying it. So there won't be any machining in the videos. I think that'll help with viewer retention and everything. The only thing YouTube cares about now is how long people watch for. It's not necessarily luck of the algorithm. I mean, I don't know, it's kind of weird. Like, the algorithm it's predictable in some ways, kind of like humans, right? It's predictable in some ways and completely unpredictable in others. The important thing is that people watch, the whole video. And most of my videos or I should say all of the videos that have machining in them, a lot of people skip past the parts with machining in it. So that's obviously not, and it's, kind of awkwardly the part that takes the most time to make. It takes, a month or 2 months to build an engine, and then it takes, a week to film all the assembling and flying, and then another week to edit all the video. And so it kind of sucks to see all the most of the work ends up not getting watched. Everyone just skips past it. I know there's plenty of people that don't, but so that's where streaming comes in. I think the streaming thing will work pretty good, so long as I can put up with it. I don't like having someone leaning over my shoulder, so it's going to take some getting used to. It's very distracting. That's 85 deep. 50, 60, 70, 85. And that's got to be 474. 74 minus 539. So we're going to call it 0.537. Give ourselves some wiggle room. And we'll go 535. 30 and a half. I kind of want to just cut out most of the machining just because it takes it like my work method sort of is very fast and fluid, and when I have to jockey cameras around it, it completely ruins my flow, and it actually makes all of this stuff take way longer to do when I'm shooting video of it. But if I can just stick the camera on my head and do live streams, it really helps a lot with that. That's up 10, 20. And so I can kind of just work more naturally and more quickly. That's the idea anyway. And I have sort of that's called the curse of knowledge, where I don't necessarily know like what's interesting to people or what people know or don't know. Right? Like I kind of took to machining like a baby to a bottle. This stuff is just like supernatural to me. This is more natural than just like day-to-day life is to me, right? So it's actually really, really difficult to make a video about machining that makes sense to someone who isn't already a machinist. I really struggle with that because I understand it on such a deep, intuitive level, if that makes any sense. I'm not sure if it does. It's kind of hard to describe. This is why it sucks that it's such a shitty industry to work in, because it's kind of the only thing I know. At least I'm just doing this full time now, but almost there. A little more. Cool, there we go. That fits in there. Just nice and snug. Okay, cool. So we've got our arbor. Let's kind of skim a little more, should we? It seems pretty snug. It's a little too snug, I think. I think we'll skim just a touch more out of it. Okay. That'll probably fit a little better. Yeah, much better. Okay, cool. We'll do that. So, there we go. It's all the boring bar work. Now we need to deburr it a little bit. That's kind of the plan. It's as I can sort of tolerate it. I'm not terribly sociable, so being live is a little bit exhausting. I think as I get more used to it, it'll probably be better as we go. The lathe is a shoreline lathe. I mean, I'm out here often enough, so I might as well be streaming basically all the time. There's not a whole lot of reason for me not to. Some days are off, I think later in the day, and some days during the like Sundays are pretty much off limits when the whole neighborhood gets home from work and stuff, starts making noise, and a lot of people have parties over the weekend. I don't want my VODs to get caught up with copyright claims and stuff. That would really suck. It would really not be fun. Make sure everything's really nice and clean because we're going to glue this together. Hey, that one made it. Cool. And okay. So what I'm going to do, I needed to put fresh acetone in this because it's dirty, but I'm going to first get most of the junk off of this thing, and then I will go and clean this out and then put fresh acetone in it. And then we'll clean it again. It's dark over here, isn't it? Jeez. Okay, so there's roughly cleaned. And I will go take this outside real quick and clean it out. I will be right back. Yeah, the V8's a 4-stroke. I will be right back. I'm gonna go clean that tray out, and I'll be back in like, I don't know, 2-3 minutes. Hey, how you doing? You're just in time for me to step away for 2 minutes. I'll be right back. Hang on. Okay, we're back. We got some fresh acetone. My videos do get a lot of views, but they basically, this is all I do. This is my full-time job now, and I basically work all day, every day, for months, just to make one. I mean, these engines take forever to make. So it's not even a matter of do they take more time to make, it's do I have more time to make them? And the answer is really no. So that's what I'm hoping the live streaming will help. And he'll be able to see too, in kind of real time, how long it takes. It's kind of crazy. Let's whack that guy back in there. I'm gonna let him soak for a few minutes. Get acetone all over my fingers. Certainly healthy. Some more Q-tips. Make sure this guy's really good and super clean. You haven't left yet. We're building a four-cylinder, sorry, not a four-cylinder, a four-stroke single cylinder for my airplane. It's one that I designed. I'm getting that question an awful lot. I wonder if there's a good way that I could maybe make a chat command that'll mention what we're building. Okay, it's probably clean enough now. Okay. Back. Probably should have washed my hands, but oh well. Too late now. Oop. Oh, there's one thing we need to do before we stick it in there, because we don't know how long it is. We're not going to be able to take it out and measure it, so we better measure it before we glue it in there. It is currently 856 thousandths. Hey, wait a minute. It's supposed to be, it's supposed to be 840. Okay. It's like, wait, it's short. No, it's not. 855.6. Yeah, 856. 856 OAL. Okay. Oh, dude, yeah. It's amazing how much those Chinese engines are, how affordable they are. It's incredible. It makes me really feel bad for the people that have to make them, because there's no way people are making a good living like that. This one's 4.5 cc's. Okay, there's that. Now we need the glue. Yoink. Good as I thought it was. Oh, I'm about to sort of dox myself a little bit. I don't live there anymore, but this is usually buy this at the hobby store locally. I was about to dox myself. Not that you, not that you couldn't figure out at least roughly where I live by some of my videos. Okay, super glue there. I'm gonna put some super glue on the end here, like that. And because I want to actually finish this thing today, oh, we better get the tailstock in there real quick. I don't always use accelerator when I'm doing this, but sometimes I do. Have to be quick about it. Get in there, you rascal. It's starting to go off already. Okay, cool. We made it. Just barely. Accelerator makes it go off in like half a second, so you gotta be quick. So what are we gonna do in the meantime while that glue sets up? It needs a few minutes. Get rid of my old soda. I'm not sure I'm gonna make the connecting rod yet. I've been kind of thinking about it. I think I'm gonna make 2 spuds that fit on the lathe, or sorry, that go on the rotary table to do the ends. But I don't think we'll be able to hang it out in space on the rotary table and then cut these. So I think we'll have to cut these separate. I'm gonna make it out of this right here. So I'm kind of half thinking we'll clamp it down like this, just on a piece of whatever, and then drill the 2 holes, and then cut the groove, and then cut the side thing, and then, well, but then we'll have to flip it over. What's that diameter there? I can't remember. It's 216. 216. Okay, this is 1/2 inch wide. Oops. 432. So maybe we will. Maybe we'll just cut it off. We'll hold it in a vise hanging out halfway. And we'll cut it down halfway. And then we'll flip it over and we'll hold it in a vise again and we'll cut it down halfway again. Because we got to put that groove on both sides. Yeah, this one's a 4-stroke. Here's the cylinder head. Yeah, the airplane looks like it should be fun. It's fairly light too. It's lighter than I thought it would be, which is good. Because this engine's not going to be very powerful at all. The excess friction does not help you small scale engines. Like it's the engine, the V8 is about a 60 size. It's a 10 cc's, and I think it's not going to be a hot rod. It's going to sound cool, but it's not going to be a hot rod, I don't think. Yeah, I think that will actually probably work pretty good if we just hold it and we do like half and half. So if we cut it down halfway, well, it's only 150 thick. Oh, you know what? It's only 150 thick, actually. You know what we could do? I might have to make a custom parallel for it because this is 1/4 inch thick. It's 152, I think. 154. 154 minus point. Oops. 250 minus 154. So it's 96. Oh, we can hang on to 96 thousandths. So if we make, oh yeah, cool. So what we'll do, we'll make a set of parallels because I don't have any that are tall enough. I'll have to make a pair. That'll leave us, 80 thousandths from the top of the jaws. Then we can do the whole thing. So we'll cut it out kind of, it'll end up so that we'll drill the holes, and then we'll cut this end square, and we'll cut this end square, and this end square, and this end square, and we'll cut the inside, right? So that'll be this feature here. So we'll cut it like that, and then we'll put the groove in it, and then we'll make sure these are the same size. Then we can flip it over and hold it by these, and then face it off to thickness, and then we can put this groove on the other side. Then we'll make some spuds that we can hold in the chuck on the rotary table, just like we did for the camshaft, and that's what these angles are here for. And then we'll just go in and do the radius on those on the rotary table. Yeah, that's a good plan. That sounds like it'll work. Yeah, it probably wouldn't overheat. I don't think it would. Small model engines actually, you can a lot of those really small ones, and the cylinders on the V8 are very small. They're what are they? It's 10 divided by 8, so they're what, 1 1/4 cc. They'll run very cold, so especially with glow fuel, because it's primarily methanol, Methanol fuels run really cool. So it would work just fine in an RC car, I think. I don't think it'd be a big issue. It's a lot of work though, man. 500 and something parts, so if you're gonna do it, you better be ready for it. So how long is it? What do we need? How long do we need? 220 plus 141 plus 0.2, oops, 216, inch and 577, so we'll go plus 0.100 thousandths. Inch and 650 should be close enough. Ugh. Okay, there's our connecting rod. And so we need some parallels. I'm not sure what material I'm going to make them out of. I've probably got maybe that. Maybe that'll work. Don't know how tall they need to be. So they need to be... So that's 877. Does that sound right? $876. So if those are 876, a beard hair? Man, I haven't had a beard in years. What the hell? Oh, where's my fucking calculator? Yeah, it's actually kind of a curse to work this fast. It's good in some cases, but I run headlong into brick walls pretty often. 876 minus, how deep did we say? 80 thousandths? So they need to be 796 tall. I think the tallest ones I have are 3/4, so use this for something, whatever that, what the hell is that? Oh, it's a wheel cutter. We'll use this thing, whatever that is, and yep, that'll work. So we'll make 2 of these that are, how wide is this? 2 inches, right? Yeah, 2 inches. So is this 4 inches? That's close enough. We'll make it work. So we'll saw off a piece of this. Should we saw it off? Should we just go this way? I don't want to go that way, but probably should. So I have full width. Yeah, we'll go that way. Okay, so we'll saw this thing off like this. It's going to be noisy. It's actually, the power is a little more complex than just 50% of a 2-stroke, because 2-strokes don't make power for the full swept volume. So the full swept displacement, right? So a 1cc 2-stroke isn't like the engine's not making power for the full 2 swept cc's, right? It's only making power until the exhaust port opens. Like a 2cc 2-stroke is a lot closer to a 2cc 4-stroke than you might think, because the 4-stroke is going to make power for pretty much the whole power stroke for the whole swept volume, if that makes any sense. My Sharpie is giving up on me. But I don't know. The big problem with model engines is more just it's like thermodynamic. And yes, making the valves will not be fun. Actually, it's going to suck. These ones weren't too bad because they're pretty big, but the V8 valves are going to be rough. Faith, no, the RC engines typically run on, it's called glow plugs. I don't want to get too involved in how it all works. I've been thinking of maybe making a video about it at some point, just to kind of describe it a little better, because it's a question I get pretty often, but it's kind of somewhere halfway between spark ignition and diesel. It's kind of a goofy way. If you look up online, you can find out how it works, but it's a bit involved to describe it midstream. Okay, so we'll saw that guy out. Hopefully this shouldn't take too long. I'm going to turn the volume down for you guys because I don't think you're going to want to listen to this. Turn that down some so you guys don't have to listen to the... I'm going to be a little quiet, but hopefully you don't have to listen to this thing squeak. Plug my ears too, because I don't want to listen to it either. Do that, or do I want to... I think I want to do that. That's going to be a pain in the nuts. Let's go halfway, do another cut. So 4 inches 200, so 2 inches 100. Yeah. This gonna work? It's kind of goofy. Let's go like that. We'll just go sideways. Really could use a better vise arrangement. This kind of sucks. Oops. Okay, there's one. Okay, there's two. Cool. Back in there. Turn the mic back up. Okay, mic's back to full. Yeah, it is. It is definitely getting the valves to seal is a problem. This one they worked out good. I left plenty of wiggle in the valve stems, so they're able to kind of figure out where they want to be, no problem. And I turned the bores for the valve guides, and the valve seats themselves at the same time in the lathe. So I think we have a pretty good shot of that working out. Yep, cool. Which way do I want to put these in there? Like this. In there. Fix that light. See what we're doing. And I think we'll make these parallels real quick, then we'll go back to the camshaft. It'll give it plenty of time to set up. Plenty of time for the glue to set up. Half-inch collet. Half-inch end mill. Okay. Let's go ahead and switch to high gear. I've already got a dent in my head. It leaves, it's got a bunch of like little rubber dots in it too that leave like a little sort of grid pattern. It's kind of funny. Yeah, I've seen people that use O-rings for pistons, but it doesn't seem like they last that long. I don't think they would work well at high speed. I'm going to use it, if you've heard of it, the Trimble method for making piston rings. I've already made the fixture. I haven't made the rings yet though. Fixture's right here. Here it is. I gotta put the pins in it, but so I'll make cast iron pistons. I don't know if I'll do it on stream because I don't know how well it's gonna work, but we'll see. I might, because I can't do the heat treating part on stream because I don't want to take the camera outside. I don't want to have to take all this crap apart and bring it outside and I'm not gonna do it in here, so. Which engine? The V8 or this one? I'd like to have this one done by the end of the week, but I don't know if I will. We'll see. The V8's probably gonna take a few months. This one, yeah, should be a week or two until this one's done. I don't know how long it'll take to actually get the video out once the video's done. We'll see. It'll get done when it gets done. And 50. So we can use the shortest ones. Yeah, easy. And then just to double check, we wanted this minus 80. 795. How tall was I going to make them? Forgot. Yeah, this minus 80. It's 876. Yeah, 875. Okay, we'll call it 875. Minus 80, 795. Did I make these tall enough? Oh, yeah. Does that sound right? 795? Yeah, it looks right. Yep, heaps more live streams to watch. And I agree on the heat treat oven. I'd love to have one. It would be very useful. Although I wonder, for a lot of things, I might not actually end up using it for a lot of things. Because most of the stuff that I heat treat is like screws. It's like screws and cutting tools and stuff. It's usually pretty small. So I usually just do it with a torch. Which works pretty good most of the time. Oops. Heat treating is sort of one of those things where you start actually getting into it. It becomes kind of a fractal web of all the different types of tools that you need. all of a sudden, yeah, you can like heat treating alloy steels and stuff. You need like salt bath and all sorts of crazy crap to soak it in. But it would still be handy. I still want one. What I really want is casting equipment. I really want to be able to do some casting. Like casting sounds like a ton of fun, and it would open up a lot of opportunities for different stuff to do. Having to make everything out of bar stock is pretty limiting in some ways. So being able to make stuff from castings would be really cool, I think. We got inch 26, inch 26, inch 25 and a half. Yeah, that's fine. 1.026 minus, forgot what it's supposed to be. I didn't write it down. Of course not. 795. $231 thousandths. Cool. Okay. How did that get to minus 4.5? To hell. Damn thing. I set my 0 and I want it, damn it. Nah, it's not that critical anyway. Let's touch it. Come on. Whenever you're ready. There it is. It's probably, yeah, it says 0, so we're going to call it minus 1. And we need to go 230. We could probably do that all in one shot, but I don't want to bend the parts. If we take too big a cut, we risk bending them apart, and I don't really want to bend them. $231, right? Yeah, 231. It's not 131. I just went way past it. Gone further than that. Sure. Take it. This is the part where we check it, and I realize I did the math wrong, and now it's 100 thousandths too small. Nope. Try it on size. Cool. Oh yeah, it's just extra set of parallels. Yeah, I was thinking for I do have a resin 3D printer, so I was thinking of getting some of the wax resin that you can make casting parts out of, but then I remember how much I hate computers and dealing with computers, and I think I'd rather just make them out of wood. Plus, foam kind of sucks because you got to remake the pattern every time. But that's how Engine Taro does his engines. That dude's cool. $7.95. So, yep, cool. Yep. Cool. So there's our parallels for the connecting rod. And put those up there for safekeeping. And once we're done with that, then we'll start on the connecting rod. Okay, how's this look? Is it all cured? Should be. Let's pan this guy back around. Done with the milling machine for now. There we go. Ow, ooh, ow, what the hell? It's not moving. We'll probably get away with it. Time is, how long have we been live? 4.5 hours? Stool. Ugh. Well, you know what? This is going to be pretty loud, so I might actually turn the mic gain down again. At least until we get through the gear. This gear is very loud and angry sounding. So our overall is 840, but it is now currently, I wrote it down somewhere. I know I did. Was it 854? Or was it 876? It was 876. No, it was 854. That's how long it was. So 854 minus 840. There's too many numbers written down. I don't remember what they are. 840 is 14 thousandths. It's easy. 14 thousandths. Probably do that in one shot. But you should be out in your shop. You should have this stream on the corner, sitting on your bench in the corner, while you're out in your shop working. That's absolutely correct. Okay. Now we need that right there. 170. 50, 100, 150, 60, 70. Okay, looks like we're right up against the... Yeah, perfect. Yeah, cool. 170. Okay, this might be super loud. We'll give it a try. Oh, good, yeah. It's the biggest relief when you can kind of step away and relax for a few minutes after spending too much time stressing about stuff. This might be super loud. I don't know. We'll see. We'll give it a shot. Not too bad. Okay, cool. We're through it. Probably a little too fast. Oh, cool. It's an easy number. 290. 290 minus 156. 67. $50. 60, 60, 65. 7. Hopefully I didn't go too small. Now that I think about it, I should have gone a little bigger than that. Nope, it's fine. See it right there. And then we need to go cut a step for the bearing, which I think is just 10 thousandths. Yeah. Is it not already fast enough? Oh, people have converted weed eater engines. That used to actually be a big thing before a lot of gas engines for model airplanes came around. Actually, people used to do that a lot. Actually, pretty common. Okay, cool. So that's done. Now we just need to polish it, deburr it, and wait until tomorrow until we can take it out. Yep, cool. Okay. Chamfer on it. And that's our finished camshaft. Of course, it's locked away in purgatory until tomorrow, and we can soak it out of there with acetone. So we'll take them out. Just make sure, just double check, make sure I didn't forget to. We can always polish it later, but oh yeah, see, it's a little snug. It's a little snug. Might as well polish it now. Well, it's already in the lathe. Polish it down a little smaller. Well, my job is a YouTuber now, but I used to be a professional machinist. That's where I learned to do all this. Still more. I think the other one needs some polishing too. It's still a little oversized. It's just Tamiya sandpaper. I use Tamiya just because I have it, really. It's just what I've got laying around. I use it for other stuff too. I think that's 400 grit. Cool. There it is. All right, we're done. Camshaft's finished. So now we just need a connecting rod and carburetors and piston rings. So we're going to put this guy right in here, and we're going to forget about him until tomorrow. What am I thinking? Should we, I think we should definitely at least start on the connecting rod. What time is it? 3:42? I think we can at least do the roughing, or well, not really roughing, but I think we can, yeah, do the first milling operations on the connecting rod too. Let's do that. I want this engine finished. I need to get a video out. Okay, so let's do some cleaning up though first. Put this with the parallels up there. This guy away, put that guy away. And I've made every part on this now, so we can put it away. This up here, 1144. Okay, so I'm going to run inside and use the restroom real quick. I will be right back. 1 moment, please. Okay, I'm back. Restroom has been used. I found the plans for my steam engine on in a magazine, Strictly IC, but they're available online. If you search George Britnell steam engine, here I'll type it in the chat so you can search it. Actually, I'll just go grab a link. Hang on one second. And I think these plans aren't perfect. Okay, here you go. These plans aren't perfect, but they're not bad. They're workable. You might have to do a little bit of fumbling around with them to get them to work just right, but that's just basically the same engine, so. I found the plans in Strictly IC though. Those are the ones I used. I redrew some of the parts too. Okay, where are we? Guess let's clean up the lathe a little bit more. This crap off the ground. Get over here. More messy. Probably this one. Okay, so we don't need the row tab for now. Actually, well, let's see. I think we can get away with leaving it on there though, because we're gonna need it later. This guy. Oh, jeez. Gonna be long enough? Oh yeah, it will be. Okay, that's fine. That, like this. Make sure everything's nice and clean. Oh yeah, we can turn this guy. Aim it up a little. How's that look? That look pretty good? Zoom it in some. Oops. How's that? That'll work. It's tolerable anyway. Oh man, look at that. I nailed it. Just eyeball it right on the money. Nice. Oh, uh-oh, it moved. What should it move? Okay, no, it's fine. Oh, because I bumped it, duh. Yeah, cool. Okay, so we need to put this thing in there. Deburr it first. Let's see, where's my file? I put it away. Here it is. Use that one. Is that it? Oh, that's the number 2. That's fine. Let's see. It's a dent there. Let's go this way. Parallels. Doink. Okay, we'll smack that guy in there. He's gonna go this way. Sneak him in there like that. Yep. Sure can. Cool. Yep, good. Okay. Yeah, he has built some outstanding. That George Britnell has done some outstanding work. Did you see his? I think it was a 3-speed Ford manual transmission, but it was like this big. And he made the whole entire gear case manually. Just it's one of those things that if someone's not familiar with machining, they don't realize how insane that is. That dude is on another level, man. So 188, and then that one's 313. So we'll have to bore that one. So let's you know what we'll do? Let's 313. Do I have a 313 reamer? I might actually. I don't know. Maybe I don't. 736, 218. 29. Nope. That's 38. Nope. Doesn't look like it. Damn. Okay. So should I could bore it, the boring head, which would be kind of annoying. Maybe I have a 313 end mill and I could just do that because it's getting a bushing. I'm gonna stick a bushing in it, so that's 3/8. 313s. So maybe if we use this guy, we'll just make the bushing fit. So I think we'll do that. We'll just drill it out and then run that guy through there. Then instead of having to bore it and make a bore gauge or a plug gauge and all that crap, we can just make the plug gauge fit or make the bushing fit that whatever this comes out to. Cool, we'll do that. That'll be easy. So, to get started, let's get some dimensions from the CAD machine real quick. Shove all the parts of the engine out of the way. GoPro cap. Put those up there somewhere. All these guys. Grab them all like that. I'm going to stick them in this tray. This is other parts for this engine. Stick them all in there. Put them up here for now. I'm going to put this over here actually. I don't want that to fall and take everything down with it. That would really suck. Okay, CAD machine. Come on now. And we're going to go connecting rod. Separate window. So the funny dimensions we need are where to put the end mill for these, basically where these radiuses are. It's a 1/4 inch radius. So I think, yeah, we can use 1/4 inch, it'll be fine. So I'm going to activate a sketch here. Project the whole top of it, that's fine. Actually, just have these dimensions right here, they're all we need. So how does this dimension? It's dimensioned off of this one, isn't it? Why is that not dimensioned there? Okay, we can find that easy enough. So we're going to use this as our origin. Dimension from, actually, you know what we'll do? We'll go from the center instead, that'll be easier. But that means we have to make this goofy line here horizontal, and then we make 2 more lines like this and make them equal. And now that's on the center of those 2 holes. So this guy can't move up and down, so the dimension from here to here, so from there to there is 348, 348, and because we're going to go in with the rotary table later, I want to leave some wiggle room, so we're going to go to 345. Then also going to dimension from here to this one. It's going to be 459, so that one is 450. So 459 will go to 455. And then the X value, so those should be 1/4 inch radius. Yep, they sure are, or 1/4 inch diameter rather. From the center to this one, 218.7. So from here to here is 0.2187. We'll go 2185, it's not really super critical. And this one is going to be the same. Yeah, that makes sense. So yeah, 0.2187. Cool. That should be all we need. Oh, let's see. Oh yeah, that's going to be this guy's 216. Yeah, we'll just calculate it. Not a big deal. I think that should be all we need. Oh, we need the location of that guy. We need this dimension from the center to here, and the center to, center to here. 390. So this way, here from the center is going to be 0.390, and then from here to here is going to be 335. If I remember right, that's a 1/8 ball end mill, 30 thousandths deep. I hope I have a 30 thousandths or a 1/8 ball end mill. Not totally certain I do. 85. Oh, it's 93. Never mind. Yeah. Okay, cool. Should be what we need. Oh. Grab the spindle. And my music stopped an hour ago again. Go ahead and get something going. How's that? What should we listen to? Allegiant, sure. Which album? Yeah, that one. Okay. 3/8 solid holder and an edge finder. Hey, get in there. Double check real quick, just make sure we've got enough wiggle room to get the whole part in there. It's 154. I think we should have plenty. Oh yeah, we got 170. We got room. Cool. Okay. Oh, you gotta plug it in. X. Oops. We're gonna clear. Yeah, I'll be fine. White. Oop, okay, now we need to. Just one thing I wish the Shoreline had is a half function. So you have to calculate it. It's kind of annoying. So 1.89. 2 divided by 2, 946. So there's center and X. I'll do the same this way. 6 nice 0.6 nice 5 divided by 2, 49. That sounds right. 349.5. Come on. 3495. Okay, 0Y. Does that look about right? Looks like it's in center. Yeah, cool. Let's move our light again. Oh, come on. I don't know why this one gets stuck in there like that. All the other ones don't. This one does for some reason. Okay. 1/4 inch solid holder. Is that a 1/4 inch? This is 1/4 inch. That's 3/16. 1/4 inch end mill. Which one should I use? That one's kind of long. That one's kind of short. How's it look? Looks fine. Let's use that one. Having with a corner rad would be better, but I don't think I do. This one's got a corner rad, but it's got a coating on it. It was a little shorter, but it doesn't have a corner rad. That's not enough different to care about. Yeah, that's fine. This one will work. Okay. Probably a little too fast. Oh, damn it. Didn't quite make it all the way off the edge. That doesn't really matter. Yeah, that's fine. Okay, cool. So that's 0. So now let's go. I think these are gonna, their first x value is gonna be 216, 216 plus 0.125, 241. It's gonna be, yeah, okay. So let's go down here. I want to go down just about as far as I can. We don't want to go all the way because the shear line does flex enough that if you go too close to the jaws, it will actually flex enough that it might hit the jaws. So you gotta be kind of careful of that. Two 41. Well, I wrote X there as in Y, but anyway. Oops. Okay, cool. Yep. Go back and do this side. Okay. So for this guy, it's inch and 220. 220 divided by 2 plus 216 plus 0.125. So we're going to go 951. 951 this way. This isn't X, it's Y. This is going to be X. It doesn't look like an X, does it? There it does, kind of. So the other side is going to be 220 divided by 2 plus 0.141 plus 0.125. Yeah, 876. 6.876. Okay. So this side's, I'm going to make sure to doodle some drawings on here so that I don't put the holes in the wrong spot. So this is going to be the big end. If my Sharpie wants to write or not, that's cool too. You know, you do you, champ. Okay, so that's going to be the big one. This is going to be the small end. Okay, so the big end, we're going to 951. Does that sound right? I'm not really sure. It might be close, but yeah, should be right. Oops. This side we're going at 876. Okay, cool. The max RPM of this one is 2,800 RPM, but you can get a pulley set to go up to 10,000, but it's not really necessary. 2,800 is plenty fine for most everything. Okay, so we're gonna cut the grooves in it on the side, and these are gonna be kind of annoying. Won't be too bad, but so our Y value is gonna be that, and our X values are gonna be these. So on the big end, we're gonna go to 345. Start at 345. And we're going to go to, so how do I want to do this? Do I want to do it at full depth or do I want to do it at partial depth? I think we'll do it at full depth. We're going to go up to 445. So we're going to go y minus, we're going to go to y positive 218. Yeah. We're going to spindle speed a little lower so it doesn't hopefully chatter too bad. It's going to want to. Not sure how much we're going to get away with. We can go pretty far. We can probably go most of the way there, actually. If we're nice to it. And we'll go 215. Start at 235. And as close as we can get, 225-ish, 220 or so. Okay, now we can go all the way to it. So x345. Oops, a little further. We'll start at 345. Oh, come on now. 655, and we're going to go to y 218. Nice cleanup pass. Cool, now we do the same thing on the other side. Except this time we're going to go this way. So we're going to start at 440, 455. Yeah, right. Yeah, okay. 445. 445. Okay, and we're going to go in as far as we can. Go into 250. Probably get away with a little more, though. I don't think it really matters too much. Uh, 445. 444 is close enough. We're going to go into 220 something. So now I'm going to start at 455, 655, 454, 5. Yeah, close enough. Cool. Go around it. I don't know why I went the long way, but I did. Cool. That's kind of sort of looking like a connecting rod. That's good. So now, what should we do? Should we drill holes? Or let's do the groove in it first real quick. Yeah, that looks good. Oh, I see some comments. I better go read those. Oh, glad you could make it. That gearbox video was fun. The gearbox was fun to make, but the video didn't perform very well, unfortunately. I was kind of bummed about that, but it is what it is. So I think I double checked to make sure that I actually had a 3/32 ball end mill, but I'm not totally sure that I did. Uh-oh, I don't think I have one. Crap, why did I design it with a 3/32 ball end mill if I don't have one? Yeah, 46.5, that's 93. Crap. Why did I design it around a 93 thousandths ball end mill if I don't have a 93 thousandths ball end mill? Why did I do that? What the hell size is that? Oh, it's not a ball end mill, still matter. Do I really not have one? Man. Got an 1/8" ball end mill. I know that. Okay, what will it look like if I conveniently redesign the part to use an 1/8" ball end mill instead? Probably be fine. Probably be just fine. Let's move that plane up a little. So it's up 95 thousandths, go up 105 thousandths. How's that look? Yeah, I think that'll work. Okay, so all our dimensions will be the same. It's just the Z depth will be a little different. Let's go and open the drawings. Double check that. Oh, I gotta save this first. Let's see what the drawings say. It says still 29. Why does it still say 29? Reproject. There we go, 35. Okay, cool. So we'll just go 35 down with a 1/8 ball end mill instead. We'll do that. That'll work. Cool. Problem solved. I know I just saw one, but right here, It's got a coating, and I don't like using coated end mills in aluminum. They gum up. Well, the certain ones that do. That one sounds a mile long. Jeez Louise. Mm-hmm. Oh, okay. And so, okay, yeah, there we go. Cool. So, I gotta be kind of careful with ball end mills. They don't like to plunge, so we'll have to, instead of just feeding it straight down, we'll feed it across while we're feeding it down, so that way it stays hopefully a little bit happy. Oops, 0. 5, 4, 3, 2, 1, 0. This isn't super critical. Z depth isn't totally critical, so we're just gonna kind of eyeball it like this. You can actually get a lot closer than you might think just by doing this. Right there, it's close enough. Okay. So we're gonna go down 30, was it 32, 35? Can't remember. 35, yeah. Oops, 340, we went over. No, it's not a big deal. Okay, cool. Nice groove, yeah, looks good. Now we can drill a hole. Get out of there. Drill chuck. Spot drill. Whack that guy in there. 220, I set those on the center, so 1.220 divided by 2, 610. So we're going to X. Oops, come on out. I'm going to lock it in place once we get there. Oh, come on. Jeez Louise. 610. And around 0? Nope. Better be. 1, 0. There we go. Okay. I'm not going to move it until this hole is done. I'm going to leave it right there. I think about it. Will this fit between the jaws? No, not quite. We'll hit the parallels a little bit, but that's not a big deal. Pilot drill it. Okay, now what's the biggest drill I can fit in that? It's 230 something. It's this guy right here. It's the biggest drill I have that'll fit in there anyway. Come on, get in there. There we go. Check this guy out. Ugh. And we need this guy. This isn't a very good way to make a precise bore, but it's the way we've got, and it'll work. It'll do the job anyway. This guy's gonna want some oil too. Oh, spit the parallel out. Oh. Put that back where it was. Okay, cool. There's the big end. Get stuck. Get out of there. Okay, now we can switch back to this guy. Do some mod. That's going to be 610 on the other side. Three, 2, And this one, I think we can just drill it straight out. It shouldn't be a problem. This guy right here. Yeah, that'll be fine. We can just blast it straight through there. Don't need to pilot drill, just drill. Reamer. There's my 188 reamer. That one? Nope, nope. It's not that one. Is it this one? Yes. Oh, get out of there. Hey. Oh, tell me I have the Z-axis travel. Oh, come on. You kidding me? Stupid thing. It's just like 200 thousandths too long. That's so dumb. We can fix that. Jeez Louise, man. Who the hell tied this thing up like this? There we go. Okay, this is going to be loud, so I'm going to turn the mic down. This is a problem we can solve with horsepower. Stupid reamer. Okay, that's a little better. Now it should fit. Ooh, that's very hot still. Imagine that. Genius. Much better. Oh, I gotta turn the mic back up. Duh. Hey, dingus. Okay, mic's back up. Go ahead and ream this guy. Yep, okay, alright, cool. That. Starting to look like a connecting rod. Mm-hmm. Oh, I think my GoPro battery is low. Sure is. Stand by one moment, please. Okay, fresh battery in the GoPro. Double check a few things. Actually, let me just go ahead and check real quick. Make sure everything's still working. Looks like it is. Yeah. Okay. Appears to still be working. Ooh, 5 hours, 40 minutes. So I think what we're going to do, we're going to flip this guy over and machine him down to thickness and then call it quits for the day. So I think that's going to be the plan. I'm starting to get hungry, so. Does that look right? Yeah, is everything in there? Just got to cut the radius there and the radius there. Yeah, okay. Cool. One connecting rod. Oops, damn it. A nice scratch in it, dingus. I don't think this is going to work all that well for this. It'll probably work though. Yeah, that's fine. Yep, cool. All right. And I want this to be nice and flat. Yep. Just like that. Yeah, we can just do this. What was I gonna do? I was gonna flip this around, make sure that guy's getting all the sides. Yeah, let's just finish this guy off real quick and then that'll be it for today, I think. parallels. We can use the tallest ones for this. I think these leave about 120 thousandths in the jaws. Let's see what we get. Yeah, 125. So it's 150 thick. So we'll be all right with that. And I think if we might actually even be able to sneak the calipers in there to measure it. No, yeah, we totally can. That makes it easy. We'll be able to just do this. Doink. Cool. Okay. Oops. Way off. Yep, I'll take it. We only needed to cut the groove anyway, so it doesn't gotta be perfect. Oh, this isn't what we need yet. We gotta face it down to thickness first. Ugh. It's still locked. No, it's not. Feels like it. It's a little snug. Set that to 0. Where are we at? 247. That's a bunch of junk in there, maybe. Yeah, it's 246. Okay, we'll call it 246. 246 minus, what's the thickness? 154, right? 154. 92 thousandths. I'm going to do that in a couple steps. I think I don't want to risk breaking this thing out of there. 94, 92. So if we go 40, then 40, and 8, 12. Let's go with 40. Then 80, 80. $92, so I'm going to go to 90. Oops, 91 and a half. Let's go to 90. Yep. That sounds nice, doesn't it? And 92. Get a nice finish on it. Cool, there's most of our connecting rod. Not a whole lot left. Oh, we got to put the groove in it before I forget to take it out. I better put the groove in it. Better do that. Oh man, usually I can get them out like that. Where's my tiny bars? There they are. Okay, so we're gonna go to, I'm gonna fix our zero offset real quick. We're gonna go to 610. Oops, 610. 10. I'm gonna set that to 610, right? It's inch and 220. Between this inch and 220 there, yeah, okay. Divided by 2, 610. 610, 0x. 0x. I'm gonna go y0. 0. Okay. Do this again. Is that a 0? About like that? Yep, 0. Okay. And then our x and y are 335 and 390. So we're gonna go over here. And it's down 35 thousandths. Oh crap, I went too far, didn't I? Nope, not quite, almost. Oh, it was really close. $335. 3. Come on. Does that look goofy? Looks like we're going too far. 330 and 2, 3, 4, 5. Okay. Okay, cool. Nice groove on that side. There's our mostly completed connecting rod. Yeah, 155. That's apparently close enough. Cool. Let's go ahead and deburr this guy a little bit, and I think we're going to call that quits for today's stream. About all I've got in me for today. We've been live for what, 6 hours? It's 5 o'clock. Yeah, I'm ready to go eat. Okay, cool. Let's get a bit of a close-up on what we made today. Let's see. So we made, this isn't the camshaft that we actually made, but it's the same anyway. So let's switch to shop cam. So here you go. So first we made this camshaft. We made the other one, but it's in the it's in a superglue arbor right now. It's gonna take all night for it to dissolve away in the acetone. So, but it's basically the same as this one anyway. And just finished off. Well, I mean, it's not finished. We still got work to do. This is the connecting rod. So I'm thinking tomorrow, we'll probably be on tomorrow. We'll finish this guy off and start on the carburetor. Because once this guy's done, then all we have to do is make the carburetor, the push rods. I guess we need a motor mount. So here you go. That's 6 hours worth. 6 hours worth of work in the palm of your hands. Pretty cool. Yeah, well, I think that was a pretty good day's work. And I'm hungry. I'm going to go eat and goof off for a little while. And I think we'll be back at it tomorrow, probably at the same time, 11, 12 o'clock, somewhere in there. And thanks everyone for stopping by, and I'll see you next time.